All right, so this is quiz 3B, and I'm only doing this one because it's the only one that would load on my board. So have your trig identities paper out when you're doing all of these chapter 5 problems. It is very useful. So we are going to simplify the expression sine of 2 theta over 1 minus cosine of 2 theta. Now, the instructions here on the B quiz was simplify the expression, but on the C and the A quizzes, it had more specific instructions about where to head. This one just says simplify. So I do want to point out that on the formula sheet, somebody noticed, Zoe, that tan squared, oh no, not tan squared. Sorry, hold on, 2 theta. Which one was it? Sine 2 theta. There was an identity here that was almost exactly that, but upside down. Sine, oh, tan of theta over 2. So tan of theta over 2 equals 1 minus cosine theta over sine of theta. Now, you might be like, but this is 2 theta and that's theta and this is 1 minus, or, you know, and they're upside down, right? Okay, well, then cotan of theta over 2 must equal the sine of theta over 1 minus the cosine of theta. Now we look at a little more similar. This is just one way to do it, guys. I know this is not how most of you did it. It's fine. But what ends up happening now is, well, okay, this is 2 theta. Okay, so let's call 2 theta x for a minute. Is that what I want to do? Maybe. So if 2 theta equals x, then x over 2 equals theta, right? Divide by 2, divide by 2. Okay. So if this is just theta, then this is theta over 2. So it turns out that if I wanted to, I could replace this with 2 theta as long as I replace this with double its angle. Use the half angle formula, but when the angle's already doubled, half the angle is just the angle. So this ends up simplifying to cotan of theta. 1 minus, yeah. But let's do it the other way. If that confused you, don't worry. Just don't do it that way. The other thing we could do is go back to the chapter 1 things that we did and try and make a common denominator. So, not a common denominator, a Pythagorean identity. I shouldn't do these this late in the day. Okay, 1 plus cosine of 2 theta. 1 plus cosine of 2 theta. Okay, so my top is sine theta times 1 plus cosine 2 theta. Sine 2 theta. Cosine 2 theta, all over 1 minus cosine 2 theta squared, cosine squared of 2 theta, because now I've made a difference of squares in my denominator. Well, this is the Pythagorean identity now. So what I did here was simplify, and multiply by 1, I guess algebra. And then algebra was to recognize the difference of squares. And now I'm going to use the Pythagorean identity to get sine of 2 theta times 1 plus cosine of 2 theta all over sine of 2 theta, sine squared of 2 theta. So now one of my sine squared of 2 thetas goes away. And that's simplified. Sine 2 theta over sine 2 theta. It leaves another sine 2 theta in the bottom. So now I have 1 over sine 2 theta plus cosine 2 theta over sine 2 theta. Okay, well that's not what I really wanted. I did get cotangent of 2 theta, but what this leads to is cosecant of 2 theta plus cotangent of 2 theta. It's not particularly simpler. Nah. I mean, it is a little, it's not a fraction anymore, but one could argue that maybe that's simplified. But let's go ahead and also think about how could we use some double angle formulas. Maybe it'll get even simpler. Since we did the other way, I kind of know that I'm looking for cotan theta. But I am also going to try and use double angle formulas now to make that a thing. So tan sine 2 theta. Okay, so sine 2 theta is 2 sine cosine of just theta. Okay, so that's my first term. Cosine of 2 theta can be all sorts of things, and then sine 2 theta, maybe I should leave that as 1 plus. 1 plus in the numerator, and 2 sine theta cosine theta. So I'm actually kind of going back to here. I'm not going to go that way because it led to just, I don't know, other trig functions. But also in 2 theta, and it didn't get particularly simple. So I'm going to see if I can make it even simpler over here using double angle. Cosine of 2 theta, let's see. I really don't know what I'm headed towards. So I might use, because I have a choice about all the cosine 2 thetas. I might use 2, to make the 1 go away, I'm going to use 2 cosine squared theta minus 1. Since this is a plus, I don't need to worry about parentheses. If it was a minus, I would have to put that in parentheses. But since I'm adding cosine of 2 theta, I'm okay. Okay, well then the 1 minus the 1 makes 0. And now I have 2 cosine theta. This is just to show that it's squared, over 2 sine theta cosine theta. It also helps me align my ones when I write it out in fully factored form, right? I'm allowed to do this now that I've gotten rid of all pluses and minuses. That's why I chose this particular cosine of 2 theta, because I wanted that 1 to go away so I didn't have any addition. And now I see cosine over sine is cotan. That is my fully simplified form. If you got here, that's great, but consider when it says simplify the expression that it's probably something quite simple, quite very simple. All right, so verify that the equation's an identity. Now we know where we're headed. Great. So now I know that I'm trying to get to negative tan 2x. I'm going to try and tackle this side because I'm not sure how to complicate that into all of that. But I can kind of do something with this. So I'm looking at maybe the, let's see, cosine x minus cosine 3x. Where do I see something like that? Oh, that's kind of interesting. I'm looking at the product to sum identities, and I see cosine minus cosine, but it's a minus b and a plus b. Can I write x as a minus b? And can I write 3x as a plus b? I think I can. If I have 2x minus x, that is just x, and 2x plus x, that is 3x. Good. So a will be 2x and b will be x. So now I'm looking at this product to sum identity again. I'm trying to do it the hard way. I'm kind of backing it out. If I go over to the sum to product identities, I think it's a little easier. I'm gonna not try and force my way into the product to sum on the left side. I'm gonna try and use the sum to product. So now it's just cosine A minus cosine B. Great. That's what I have right here, where A is x and B is 3x. So I'm gonna do this. I'm gonna make that numerator negative 2 sine of x plus 3x over 2 times the sine of x minus 3x over 2. Okay, that's my numerator. My denominator is sine x minus 3x, sine x minus sine 3x, sorry. So I use the same thing, but now, because this is basically factoring, right? Sums to products are they're factoring. That's what we do when we factor, is we rewrite a sum of terms into a product of factors. So 2 times the cosine of x plus 3x over 2 times the sine of x minus 3x over 2. Okay, let's simplify a little bit. Oh, well, actually, before I even simplify, I see some ones here. Now that I'm in factored form, these things are identical. They make ones. So my top is negative sine. Now, x plus 3x is 4x. 4x divided by 2 is just 2x. So this turns into that mathematically. Just x plus 3x is 4x's divided by 2 is 2x. And then my denominator, that's the same angle, which is fantastic. I love when it's the same angle, because now I can use all of my, basic identities up here that always had the same angle. Until I have all the same angle, I can't really use a lot of these very much. It's dangerous because my angles are different. So now that the angles match, this is just negative tangent of 2x, which is what I was trying to get. Hooray! So if I label my identities, which you should do on the test, what I used here were sum to product, identities twice, right? Once in the numerator, once in the denominator. And then here I just did algebra, or simplified. Algebra simplification. I simplified what was inside here, and I simplified what made 1. And now here, this is the quotient identity. So, success. Now it says use a product to sum formula again. Oh, last time I guess I used a sum to product, but now I'm going to use a product to sum. So these quizzes were all pulled from 5.3 and 5.4 homework. Some of them have more of the product to sum, some of them have more of the power reducing or the half angle or double angle identities, but you can sort of expect the test to be a mix of those throughout. Use a product to sum formula to find the exact value. Okay, so I have a product, that's what this is. When they're next to each other, they're assumed to be multiplied. And I have sine of an angle times sine of a different angle, so that's the very first one. That will equal 1/2 cosine of my first angle A here, 17 pi over 12, minus the second angle B here, pi over 12. And then I'm going to subtract from that the cosine of 17 pi over 12 plus pi over 12. That is cosine of A minus B minus cosine of A plus B. I always go back and make sure I got my signs right. All my pluses and minuses. Now I'm going to simplify here, because this is the cosine of 17 pi over 12 minus 1 pi over 12 is 16 pi over 12. 16 pi over 12. Well, there's a factor of 4 here and a factor of 4 here to get a 3. So this is the same as 4 pi over 3. The cosine of 4 pi over 3 minus, 17 pi over 12 plus a pi over 12 is 18 pi over 12. I no longer have a common factor of 4, but I do have a common factor of 2. So this is now 9. Oh, actually 6. 6 will go straight through there. My LCM, my least common multiple, no, that's not right. My GCF, my greatest common factor, is 6. So this is 3 and this is 2. It's 3 pi over 2. Cosine of 3 pi over 2. Okay. Well, I know those angles. I've seen them before, right? 4 pi over 3 is 1, 2, 3, 4 pi over 3s. The cosine is -1/2. This whole thing is -1/2. Sorry, bring this down. Then I evaluate. This is the step where in Alex, it would have you evaluate the actual cosine value. So counting over to 4 pi over 3, my cosine value is -1/2. Now the cosine, I'm going to subtract, the cosine of 3 pi over 2, well, 1 pi over 2, 3 pi over, sorry, 1, 2, then 3 pi over 2 is down here. The cosine value is 0. Huh. That made it simpler, right? So what is 1/2 times -1/2? It's -1/4. So I have used a product to sum formula to find the exact value. I wrote it as a fraction. I didn't have to rationalize. It's very exciting. That's it. So if you have other questions about the quiz, you can try and email me over the weekend. But I am not probably going to post another video. I won't have time between now and then. So see you for the test on Tuesday.